Okay, so part two of the algebraic limit theorem allows us to deal with limits of sums in the way that we want. So in particular, if we have two sequences and they both converge, the limit of the sum turns out to be the sum of the limits. So this looks a lot like the previous part as far as the setup of the proof. Let's let epsilon be bigger than 0 and consider the thing we want to be small. So that's a sub n plus b sub n minus L plus k. And that's the same as a n minus L plus b n minus k. And that's a little more like a parenthesis than an absolute value, so there we go. All right, now in a lot of these proofs, the triangle inequality will appear because on the inside of this absolute value, I've got two things that I know individually I can make small because a sub n converges to L and b sub n converges to k. But it's harder to work with them when they're together inside an absolute value. So we'll bust this up with a triangle inequality. We know that the triangle inequality says the absolute value of the sum of two numbers is always less than or equal to the sum of the absolute values. Okay. And now I have to use the definition of convergence for each of my sequences to make the total here be less than epsilon. So this is, again, what I want to make happen. All right, we have a little bit more work than in the previous one. And what we're up to now is we're going to make each piece less than 1/2 of epsilon so that together the sum will be less than epsilon. But that's really not a problem because the definition of convergence works for any positive number. So in particular, it works for epsilon over 2, and that's true for both a sub n and b sub n. Right, so we'll say by the definition of convergence, there exists capital N1 such that n bigger than n1 makes a sub n within epsilon over 2 of L, and there exists some other capital N, n sub 2, such that if I go out that far in the B sequence, the difference between b sub n and its limit is epsilon over 2. And then to make both things happen at once, I have to make sure I go out as far as n1 in the first sequence and as far as n2 in the second sequence. So to make sure I've gone far enough in both, I take my final n to be the larger of the two. Now, if little n is larger than this capital N, then both inequalities, right, the inequality for each of the sequences, they hold at the same time. So then we have n larger than capital N implies, and now let's kind of finish this up, that the an plus bn minus L plus k, which is less than or equal to an minus L plus bn minus k. First piece is smaller than epsilon over 2. Second piece is smaller than epsilon over 2. Combine those, and we're done. The whole thing has to be less than epsilon, and we've established the limit.